In this video of engineering mechanics, we will see the action of frictional force on the objects when they are about to move or just about to move, or when an object is acted upon by an external force. There will be a resisting force which will be opposing the motion or tendency of motion, and this force is called as frictional force or force of friction. So the main property of an important property of frictional force is that it will always be opposing the motion, or the direction of frictional force will be opposite to that of the motion or tendency of motion of the object. Another thing is, till the limiting friction or just before the motion starts, the force of friction is having a unique property of adjusting itself with the external force. So before starting motion, if you apply a force, the body may not move, but if you increase the force, again the body may not move depending upon the roughness of the surface and the property of the materials or the surfaces in contact, but the friction force also will be increasing. That is why the body is not moving. But after some time, we will be able to move the body if the force applied force is more than the maximum frictional force the surfaces can offer. So let us see a problem in which frictional force is also coming into play. So in this video, we will consider a block of weight 90 Newton is placed on a rough horizontal plane. 90 Newton weight. We have to find the coefficient of friction between this block and the surface. If we apply a horizontal force of 63 Newton in this direction on the body. So this is the case. A block of weight 90 Newton is placed over a rough horizontal plane on which we are applying a force of 63 Newton in the horizontal direction towards right. We need to find the coefficient of friction. We know that the limiting friction, that is a maximum frictional force, bears a constant ratio with the normal reaction. If Rn is the normal reaction, okay, the limiting friction F is proportional to Rn, or this can be written as the limiting friction F is equal to mu into Rn, where mu is called the coefficient of friction. Mu is coefficient of friction. Coefficient of friction. So we need to, in this problem, we need to find the value of mu. Okay. So how we will find out mu in this problem? For that, the first step is to draw the free body diagram of this body. That means the body should be separated from all the supports, and or the supports must be replaced by uh, reactions. Okay, and we have to show the forces, all the forces acting on the body. So let this be the body. Okay, and its weight is acting vertically downwards, 90 Newton, and an external force is applied, 63 Newton, and the reaction from the horizontal surface or floor will be, let it be Rn, normal reaction. Normal reaction. Then if this is the direction of force, the frictional force must be in this direction. So this is F. This is F. So just to move this body, we need to overcome this force. That is, this force, frictional force, must be the limiting friction. So we can use the equation F is equal to mu into Rn. So this is the free body diagram. in which all these four forces are acting in various directions as shown. Now, how to find out Rn? Then if we get the value of Rn, we can find out mu. Okay, so how we will find out Rn? So using equilibrium equations in the vertical direction, because the body is not moving in the vertical direction. This body is not moving in the vertical direction, or there is no chance of moving in this direction because it is supported by the floor. So we can use the equilibrium equation sigma v equal to 0. That is the net or algebraic sum of vertical forces acting on the body is 0. So which are the forces acting in the vertical direction? This 90 Newton, that is the weight of the body through the center of gravity vertically downwards, and Rn upwards, vertically upwards. So if we consider Rn forces in the vertical direction as positive, the equation will be Rn minus 90 equal to 0. This will give Rn equal to 90 Newton. Rn equal to 90 Newton. Then, if the body is just about to move, then the frictional force can be assumed to be equal to the applied force. That is, F equal to 63 Newton. Since F is sufficient to just move the block, we can assume that F is equal to 63 Newton. That means 63 equal to mu into Rn. Mu into Rn. We know what is the value of Rn, that is 63 equal to mu into 90. Therefore, mu equal to 63 divided by 90, and it should be equal to 0.7. So this is the value of the coefficient of friction between the contact surfaces of this block and the horizontal surface. So this is how we solve problems involving frictional force.